Getting to class on time and remembering what you need to know for a big test, it's all about memory. Psychologists call such memory declarative memory. Declarative memory helps us recall facts and events, like what you had for breakfast.
I had 4 eggs, some cereal, and a banana.
Breakfast this morning, I had a brownie, a cookie, and a cup of tea.
Another kind of memory is memory for skills and habits. Riding a horse involves motor skills, perceptual skills, and habits. That's called non-declarative memory. Unlike declarative memory, we often perform skills and habits without much conscious thought. Neuroscientist Larry Squire provides other examples of non-declarative memory.
Like learning to say please and thank you, or washing your hands before dinner. These are things that accrue gradually through feedback, through trial and error, through reward and punishment.
Squire is a professor in the School of Medicine at the University of California at San Diego and a research career scientist at the VA Medical Center. He's shown that different brain systems are responsible for supporting declarative and non-declarative memory. And he's found that if brain damage destroys the structures used in declarative memory, the habit memory system survives and can support other kinds of learning. Squire says that up until 20 years ago, researchers weren't aware that separate brain systems existed for memory.
We just thought memory is memory.
But today, neuroscientists say
memory is not a single faculty of the mind. Memory is made up of multiple component systems, each of them supported by different brain structures and connections.
This 3D image of the brain shows one brain structure that's responsible for declarative memory. It's deep inside the brain, in the medial temporal lobe. It's the hippocampus. If the medial temporal lobe is damaged, it can affect declarative memory. These scans show 2 patients who had viral encephalitis. Each developed amnesia and could no longer form new declarative memories.
You see these horizontally oriented MRI scans with the front of the brain at the top, the back of the brain at the bottom, and the area in white shows the damage. In both patients, the medial temporal lobe has been completely destroyed.
Peter, who does not have amnesia, will demonstrate how the patients performed on a simple discrimination task. Peter is shown pairs of objects. There are 8 different pairs, and he sees one pair at a time. His task is to pick the correct object in each pair.
You're going to know it's correct because the correct object will have the word correct written underneath it.
Yet over several days, patients with amnesia can't master the task at all.
Can people really do this?
On the other hand, a normal control subject learns this 8-pair discrimination task very quickly.
I remember this one from last time.
But Squire believed that amnesics might be able to learn the discrimination task using habit memory. Some animals learn discrimination tasks by habit, even after brain damage.
Monkeys with large medial temporal lobe lesions learn this task as well as normal monkeys. And even rodents will learn tasks like this in a normal kind of way, as if they're using some other brain system. And the other brain system they seem to be using is the basal ganglia, the caudate and the putamen. So then the question naturally arose, well, do humans have a system like this that they can use, or are we overshadowed? Is that system overshadowed by our powerful declarative memory system? So we asked the question whether or not patients with severe memory impairment have a robust habit system as monkeys do, as rodents do, as other mammals do.
And the answer is yes, we do. So using the identical training procedure shown earlier, but over an extended period of time, patients with amnesia slowly mastered the task.
Okay, here we can see that EP acquired the 8-pair object discrimination task gradually over 36 sessions, 2 sessions a week. So this took him 18 weeks, but gradually he became very proficient at the task.
But amnesia prevents them from realizing that they're improving.
How'd you know that?
I don't know really. I would just it just goes from here out to here.
What was interesting about the learning that these patients were able to accomplish is that it occurred completely outside of awareness. That is, they never had any conscious knowledge of what it is they were doing or how they would be able to perform successfully.
But habit memory is negatively affected if the procedure changes slightly. If the pairs of objects are all placed in a big pile, memory for the correct choice collapses. Performance returns only after the original learning procedure is reinstated.
And all of that lies completely outside of awareness and outside of the medial temporal lobe system that supports conscious memory.
Squire says knowledge in neuroscience has grown dramatically in a short time period.
We know things that we didn't know 10 years ago. I mean, the field progresses, and we didn't know that there's more than one kind of memory. We didn't know that we have a robust habit system. We didn't know that we share so much with the other animals and that they share so much with us in terms of how the brains work.